Hello Math 8 students, this is Utah Middle School Math Project 7.2a, solve equations using square and cube roots. To get started, we're going to just have a quick understanding, a quick review of what solving equations is really all about and what it means. So we're going to start by solving these equations in one part A, B, C, and D. As we do this, we really want to pay attention to the inverse operation that we use. For example, x plus 3 is equal to 7. How do I solve that equation? X plus 3 equals 7. Siley. Yeah, we subtract 3 from each side. So what was the inverse operation that we used? Here we used subtraction, and that's what I want you to write down. Solving equations, whatever we do to one side, we do it to the other side, and that's why I'm left with x is equal to 7 minus 3, which simplifies to 4. The reason I chose to subtract 3 is specifically to undo the adding 3 so that I could get x alone. With that in mind, we're ready for B. Negative 3x is equal to 18. What is happening to x? Start there. What's happening to x in this problem? Sam? Yeah, it's multiplied by a negative 3. So how will I undo multiplying by a negative 3, Kate and S? Division. So I will divide by a negative 3. And just like always, whatever I do to one side, I do to the other side. The whole reason I chose to divide is specifically to undo that multiplication. And that leaves me with x is equal to 18 divided by negative 3, simplifies to negative 6. So what was the inverse operation? The inverse operation was division. C, x minus 6 is equal to negative 14. So what is the operation that is being done to x first? Peyton. Yeah, and how do I undo subtracting by 6, Peyton? We add 6. And balance it, do the exact same thing to the other side. So the whole reason I chose to add was to undo the subtraction. Addition was our inverse. And I'm left with x, which is equal to negative 14 plus 6, simplifies to negative 8. And finally, what is happening, what is being done to x in D, Daxton? Which, how will I undo being divided by 7? We will multiply by 7. So, multiply by 7 will undo dividing by 7. The inverse operation, therefore, is multiplication. Multiplication. And again, the whole reason I chose to multiply was to undo the division. So x is equal to 3 times 7, which is 21. So summarize then. What does an inverse operation do? What does an inverse operation do? Will you turn and talk to your neighbors to answer that question? Okay, and now come back and summarize to me. What does an inverse operation do? Sam? Exactly, it undoes what's been done. Did you have something to add to that, Kaden? Yeah, like reversing it, yeah. So now we're going to switch gears for just a second. It will all come back together to this inverse operation idea, but write and solve an equation to find the side length of a square with area of 25 centimeters squared. So here's the square. I don't know the side lengths, that's what we're trying to find, but I know that the area is 25 centimeters squared. Talk with your groups and see if you can write an equation for that. Ready, set, go. All right, even if you're not done, what are your thoughts and ideas here? How do we make this work? Brock. Close. I know what you're trying to say. 25 times 25. Why are you thinking 25 times 25? Tell me a little bit more about that. Okay, when it's a square, we multiply it by itself. True. However, you're thinking of it kind of backwards. The area is 25. We need to work backwards and figure out what those side lengths were. So what you're saying is that the side length was 25 and 25, and 25 times 25 would be not 25. So you're on the right track. You're thinking about the area of a square correctly. It's just how you went about it is a little bit off. So what could we do instead? Sam? Okay, that's going to be an issue then. Let's review. How do we find the area of a square? Let's start there. How do we find the area of a square? If you knew the side length, what would you do? Turn and tell your groups. Okay, and now come back. If you knew what the side length was, what would you do with that side length, Maverick? Let's get there in just a second. Since we didn't get there the first time, we'll get there in a second after we do these baby steps. If I know the side length, how do you find the area of a square? What do you do? Danielle? Yeah, we multiply it by itself. Remember, with rectangles, and a square is a rectangle, it's length times width. But squares are special where, if I know the width, don't I also know the length? Right? So length times width becomes the width times the width. Or, what's another way of writing that? No, what's another way of, width squared. So remember, when I'm finding the area of a rectangle, it's length times width. Squares are special rectangles where it's width times width is the area, or width squared is equal to the area. Maverick, would you like to go on with your equation? No, that's a good guess. A equals 25 divided by 2. Here's the issue, is we know what A is, don't we? We know what the area is. So we shouldn't be saying the area is equal to something, because guess what? We know what the area is. Also, do that. What is 25 divided by 2? You have calculators. It's 12.5. Okay, so you're saying the side length is 12.5. What is 12.5 times 12.5? Oh, not 25? It should be though, right? Because you told me that width times width would be the area. You're guessing that the width is 12.5. 12.5 times 12.5 should be equal to 25, and is it? No. So our side length can't be 12.5. So what are we going to do? I've got some good clues here. Go back and talk with your groups one more time. I want to know what the side length is for this square. What is the side length? Okay, come back to me now. What are your thoughts? Once again, I know that the area is 25. That's what it told me in the problem, and I see it in the diagram. The area is 25. So how do I use that to find the side length? Maverick? Length or width is 25 divided by 4. So in other words, 4W is equal to 25. Because how would I undo that? Okay, test it out. What's 25 divided by 4? 6.25. Okay, so you tell me 6.25 times 6.25, is that 25? That's not, is it? All good guesses, Maverick, and really truly all of these little mistakes are really exactly the point that I want to get to in this lesson, that understanding what we really need to do, we only get there by making all of these other mistakes. All good thoughts, but we're not quite there yet. What about 5? Why 5? Where did you pull 5 from? Okay, so you just knew, I don't need an equation to solve, I just know that a number times itself equals 25. The only number that works is 5, right? 5 times 5 is equal to 25. True story. But here's the equation. So what I want you to understand is all of those things that Maverick was suggesting, did any of them work? Yeah, exactly. What we really have is we have W that's being squared, and Danielle says we need something that will unsquare. Is dividing by 2 going to unsquare? No, we already said that 12.5 doesn't work. So we need something that is going to unsquare, and that is what we are going to get to in just a second. Okay, so just hold on to that thought. Let's summarize one last time. What we're really looking for is a number squared is 25. What is that number? It would have to be 5. But now let's take a look at number 4. Number 4 says, now let's consider the equation x squared equals 25. Fun fact, did you see that the equation was there all along? It was right there. Let's say we have x squared equals 25. Yeah, that's okay. Let's say we have x squared equals 25. That's just an equation. And it is no longer a context. We're no longer talking about the area of a square. We're just saying x squared equals 25. We know, obviously, that 5 works. Is there any other number that's going to work? Is there any other number that when squared is equal to 25? No? No other number? What if I told you there was a number and now you need to find it? A number multiplied by itself is 25. I'm going to pause the recording as students puzzle on that and maybe try some things in their calculator and talk with their groups. Pausing the recording now. Gabe, what's the number? Yep, because a -5 times a -5 is equal to a positive 25. A negative times a negative is a positive. Fun fact though, eyes on the screen. Type that into your calculator. -5 squared. And what does your calculator tell you? Yeah, so good. Let's use our brains. If we say -5 times -5, we know, and our calculator tells us -5 times -5 is positive 25, right? So why does the calculator, when I say -5 squared is equal to -25, why does the calculator say that? You're onto something. You're not quite there yet. Why is the calculator saying that? Is the calculator wrong? Yeah, technically no. The calculator is doing exactly what you are telling it to do. And this leads nicely into our next topic, which we're going to get to next week. Do you see the square? What is the exponent of 2 attached to? No, just the 5. So it's saying, hey, do 5 squared. What's 5 squared? Okay, and now go and make it negative. That's why it's -25. If we really want the exponent to be attached to the -5, we have to use parentheses. Because now, what is the exponent attached to? The parentheses. And what's in the parentheses? A -5. Do it now. And now it's 25. I know it's so much work, so that's why one time, maybe we could just do it in our head instead of relying on the calculator, right? We know that -5 times -5 would also work. So instead of taking all the extra time to make the calculator tell us the same thing, then sometimes our brain is a more powerful or better tool than the calculator, mostly because of laziness, but it happens. Okay, so when we write down -5 squared, let's make sure we write down -5 in parentheses squared. That way we understand that the 5 is being squared and the negative is being squared too. Okay, so here's an interesting thought then. We still have this idea that, hey, we had W being squared, we need a way to undo a square. What's that going to be? But before we explore that, I want us to move on. Now we have a cube. The volume of a cube is 27 inches cubed. I'll help you out with this one. To find volume of a cube, that means we have a side length multiplied by a side length. That would be like the area, right? But then that is also multiplied by a side length. So I have a side length times a side length times a side length is equal to volume, yes. But what is the volume? 27. So figure out what the side length needs to be. What does that side length need to be? Something times itself is equal to 27. Some students have already figured it out. Good. Let's give some more think time for a few other students. Brains are good here. Calculators are good here. Okay, and what is that number? What does it have to be, Gracie? It has to be 3. 3 times 3 times 3 is equal to 27. What's another way I could have written this equation instead of s times s equals 27? What is that? What's another way to write that? Let's go with Daxton. Great. S to the third power, or s cubed, is equal to 27. So we know that the answer has to be 3, right? We know that the side length is 3. But how do we do that? If we try and divide by 3, is that going to work? Oh, 27 divided by 3 is 9, not 3. So dividing by 3 isn't going to do it. So what's the issue? What do we need? I'm going to go back to Danielle. Danielle, what do we need? Oh, Seth, we have a hand with Seth. Ultimately, maybe we'll need to use a calculator, but the thing is, Danielle mentioned before, we need a way to undo a square. What do we need here? We need a way to undo a cube. Is dividing by 3 going to undo a cube? No, clearly it doesn't work, right? Siley? Try it. 27 divided by 3. And then squared. Well, 27 divided by 3 is 9, and 9 squared is 81. Is our side length 81? I see what you're saying. I see what you're saying. You get lucky with these numbers that it works out that way. You wouldn't normally get lucky with those numbers working out that way. You just got lucky for this particular one. So good guess, but don't get used to it because it only works for these numbers. Okay, good idea. So now let's consider this out of context as well. We're no longer talking about the volume. So we just have this equation, x cubed equals 27. Is 3 the only solution? We saw after a little bit of work that 5 wasn't the only solution, -5 also worked. Is 3 the only solution here? Talk with your groups. We'll just go a quick 20 seconds here. Okay, and now come back to me. You tell me, is 3 the only one that works? Gracie?
Yeah.
Why, yeah?
Because if it's -3, then the first two 3's will become positive.
Mm-hmm.
But since that's positive times 3, they'll just end up being negative.
Exactly right. So when we have it cubed, as Gracie said, -3 times -3, that's going to be positive. But now when I take this positive and I multiply it by this negative, what's a positive times a negative? That's still going to be a negative. So yeah, 3 is the only number that works. Okay, and we did all of that with our brain. And that's one of the things that's a big takeaway is a lot of these can be done with just your brain and you don't need a calculator. But number 7 says state the inverse operation. And Danielle was already onto it way back in the beginning. We need something to undo a square. How do we undo a square? Fun fact, you learned it last year in a circles unit. What is it, Seth? Yeah, it's a square root, exactly. How do I undo a square? We take the square root. And whatever I do to one side, I do it to the other side. So I need to take the square root. Now, that might look kind of weird. And we don't know how to undo this. But remember, just like up here, the whole reason I chose to subtract 3 was specifically to undo adding 3. The whole reason I'm choosing to take the square root is specifically to undo the square. So this and this will automatically undo. And that leaves me with x is equal to, and you tell me, what is the square root of 100? Without using your calculators, can you do that in your brain? What number times itself is equal to 100? Yeah, it's 10. Now let's also confirm. Let's type that into our calculator as well. Where are we going to see it in our calculator? Yeah, look at your x squared. Do you see your x squared button? What do you see up in yellow up above it? The thing that will undo it, the square root. So control, and then the x squared will give us the square root. And we type in the square root of 100, which is 10. Now, is 10 the only answer? What else is going to work besides 10? Negative 10. So x is equal to 10 and x is equal to negative 10. Your calculator is not going to tell you the negative. That's up to your brain to remember that. Yes, Maverick. That's exactly right. Yep. And what you mean by that is the power. When the power is even, a positive option and a negative option. When the power is odd, then only the positive option will work. That's exactly correct. Yep. So you know how mathematicians are lazy? You can write x is equal to 10, x is equal to negative 10. But mathematicians are lazy, so they say this. X is equal to plus or minus is normally what we say, but that means positive or negative 10. Yep. Okay. So what was the inverse operation that we used here? We used square root. A square root will undo a square. Let's do that now with B. X is being squared. How do I undo a square? We take the square root. And whatever I do to one side, we do it to the other side. This might look weird, but remember, a square and a square root are inverses. They will undo. So that leaves me with x is equal to, and on the other side I have the square root of 36. But again, that's probably something you can do in your head. What is the square root of 36? Yeah, it's 6. Is 6 the only one that's going to work? Nope. So negative 6 plus or minus 6, or positive and negative 6 work. And what was that inverse operation? That was a square root. And now C, x is cubed, and it's equal to 27. Now, yeah, exactly. So you guys are already onto it. X squared we undo with the square root, but is this a square? No, it's a cube. So what do we need to undo it? A cube root, exactly. Now, what does that look like? Can I have your attention? You have heard me say mathematicians are lazy 100 million times, right? One thing that we're lazy about, you know how if it's x, we're too lazy to put that 1, but we know it's 1x, right? If it's a square root, we're too lazy to put it, but secretly, there's a 2 there telling us that it's a square root. It's one of those things that we're just lazy about. That number here is called the index. So if I am trying to undo a cube, I need to take the cube root. How do I show that it's a cube root? We put a 3 for our index to show that it's a cube root and not just the classic square root. And whatever I do to one side, we do it to the other side. Now we've already done this problem. We did it in number 6 and in number 5. So we already know the answer here. Let's practice finding it and doing it in our calculator. Remember, a cube and a cube root will undo, leaving me with just x. And so on the other side, I need to take the cube root of 27. Where are we going to find that? Some of you have already found it. Good. Where did you find it, Emma? Yeah, in our template button. Next to the number 9 is our templates. You will find it there. So here's our square root, and do you see next to it how it gives us an option to place a different index? There's a shorter way. Where is the shorter way of doing it? Danielle?
Next to the square button, in control, there's a little yellow thing.
Yep. So first things first, let's understand what that button does, right? This button is called caret, and that button will give us an exponent box. 3 to the third power is 27. So how do we undo higher powers? We use the root, which is the control command. So control and then caret, and that will give us that same shortcut as going into the template box. Okay, so we're typing in 3, the cube root. Notice, it's not being multiplied, right? It's not in front of it being multiplied. It's trying to put it there inside of that little hook, the index. So the cube root of 27, we press enter and it's telling us that it is 3. Okay, for those of you who use Desmos, anyone use Desmos at home? Okay. Let me pull that up. Whether it's the app or the browser, you're still going to have those same features. Notice here is the square root. So the square root of 25 is 5. And the cube root, do you see how it has an nth root? So that we can say, I want the cube root of 27, and that is equal to 3. So you'll have those same options here on Desmos at home. All right, that is it. The cube root of 27 is equal to 3. No plus or minus, it's just 3. Only the positive works here. And now you know how to solve equations that are square, or that have squares and cubes in them. So let's put that to practice. Are you ready? Okay. A, x squared is equal to 64. As much as possible, try and use your brains. Your brains are going to help you out a lot more here. So how do I undo something being squared? We take the square root. Whatever I do to one side, we do it to the other side. Oh, I'm sorry. I'm going to be a good example. We were supposed to write the inverse. What was the inverse operation here? A cube root. Yes, Fitz, hand. No, if we decide to use a different variable like n squared or something like that. Yeah, no, the variable doesn't matter. A variable, like you'll see down here, p is a squared, q is z squared. That doesn't matter. It's just a variable. Yeah, thanks for asking. All right, what is the square root of 64? What number, when multiplied by itself, gives me 64? Brains first and then calculators if your brain's just not working. I believe I've called on all the hands that are up. Let's go Peyton. It is 8, yeah. X is equal to 8. 8 times 8 is equal to 64. Is that the only one? No. What else works? Negative 8. Whether you write it the lazy way, plus or minus 8, or you write it the unlazy way, make sure that you include both the positive and the negative. B is a really good one to think about. No calculators on this one. X squared is equal to negative 64. What number, when multiplied by itself, will give you a negative 64? I'm going to pause the recording as students think about this. With your groups, ready, set, go. Okay, Sam, what are your thoughts here? Yeah, a number multiplied by itself will always be positive. Whether we try 8 times 8, that's going to be a positive 64. Whether I try negative 8 times negative 8, that still is going to be a positive 64. So can I ever multiply a number by itself and get a negative number? That's if we're limited to the real numbers. No real solution. No, there are not fake. There are imaginary numbers. And you will learn about imaginary numbers in 10th grade. There's a reason we wait until 10th grade. Your brain needs to not blow up when you learn about them. So you need a little bit more learning and experience first. But when you see something like this, no real solution, imaginary. No, not any negative. Negatives are not imaginary. Oh, any negative. Close, close. We're going to find one that we'll skip ahead to a different one so that you can see what I'm talking about. Let's see what happens when we type that into our calculator. The square root of negative 64. And what does it tell you? Non-real calculation. So what does that mean? No real solution. No real numbers. What's that? You eventually can. You have to change the settings. But we don't need to worry about imaginary numbers, so I'm not going to change the settings. But eventually, you can do these in your calculator. Real quick, let's do C, and then we're going to skip ahead to answer the question that was asked before. What is happening to X here? What's happening to X and C? Sam? Yeah, it's multiplied by itself 3 times, or in other words, it's cubed. So how do I undo cubing something? We take the cube root. We uncube it, yes, by taking the cube root. So the cube and the cube root have undone each other. That is the inverse. And now I'm left with the other side. I have the cube root of 8. Heads first. See if your brain can figure that out. And if your brain can't figure it out, then you can resort to the calculator. But 2 times 2 is 4 times 2 again is 8. So x is equal to 2. Does negative work? Negative 2 times negative 2 times negative 2, is that still going to be 8? No, so it does not work here. With that in mind, we're going to skip ahead. Oh, I guess we're not skipping ahead. We're going to go to D. Yes, Daniel.
So if negative 2 to negative 2 to the cube 1 equals negative 8, then that means anything that's cubed with a negative answer would work.
Exactly right. Yep. So we try negative 2, and negative 2 times negative 2 is 4 times negative 2 is negative 8. That's why negative 2 doesn't work here. But with that in mind, let's look at D. What number multiplied by itself 3 times will give me negative 8? It's going to be negative 2. So, Gabe, you asked, is that always the same with negatives, right? How come we were able to find a solution here and not here? What's that difference? A few hands are going up. How come it here, when it was equal to a negative 64, it was no real solution, imaginary numbers. But here, when it's equal to negative 8, it works. Good, a few more hands. Seth. Yeah, exactly. Here it's to the power of 3. Here it's to the power of 2. So any number multiplied by itself will always be positive, but any number multiplied by itself and then multiplied by itself again could give us a negative number. Again, let's test that one out in the calculator. I want to undo by taking the cube root. So control caret gives me the cube root. I want to take the cube root of negative 8. And it is going to tell me this time, oh yeah, I can do that. That's legit. That's negative 2. Okay. So what work do I show here? I'm taking the cube root of each side, and the cube root of negative 8 is negative 2. Okay, for the sake of time, let's skip ahead a little bit. Let's take a look at I. Now let's take a look at H. X squared is equal to 10. Can you think of any number that this is going to work for? No calculators. What number multiplied by itself is 10? I can start going through. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. So is it going to be any of these whole integer numbers? No. So we know that the square root of 10 is going to be somewhere between 3 and 4, yeah? All right. Let's type it into our calculator. Let's see. The square root of each side. X is equal to the square root of 10. Oops. And not what I wanted to type in. Let me try that again. Square root of 10. What do you think? Is that a nice number? No, that is not a nice number. And so what we write down is this. What is the square root of 10? It's the square root of 10. Don't forget, we still could have the positive or the negative. No, because it's all about simplifying, right? Just like I don't want you to write 3/6, I want you to write the simplified version 1/2. It's the same thing. And Maverick, our very next lesson is going to be on simplifying these correctly. We can simplify them the same way that we do fractions. And here is the answer to that question, Maverick. Here's our number systems, a Venn diagram that I used to do with my students in years past, and I don't do it anymore. But we start with our natural numbers. That would be 1, 2, 3, 4, etc. It expands just slightly to our whole numbers, which now includes 0, 0, 1, 2, 3, 4. And then we also have the integers. You guys remember integers from last year, which are all of the negative versions of those whole numbers, right? I should be on the screen right now. Our system then expands to what we call rational numbers. That is why this unit is called rational and irrational numbers. Rational numbers are any number that can be written as a fraction. Even if it's not necessarily written as a fraction, if it can be written as a fraction, then it is a rational number, like repeating decimals. So 0.3 over bar can be written as 1/3, so it is a rational number. 0.75 could be written as the fraction 3/4, so it is a rational number. But now we have reached the point where not all numbers can be written as fractions. What cannot is called an irrational number. You knew about pi last year. Pi is an irrational number. It never repeats, so it's not a repeating decimal, but that decimal continues on infinitely without repeating, just like many square roots. Square root of 10, square root of 20, square root of 5, square root of 3, square root of 2. So when you have an irrational number, instead of trying to write down all of those decimals that you see, we just write it in accurate or exact form, and we just write the square root of 10. With that in mind, let's take a look at I. What number multiplied by itself 3 times is going to be 15? Let's kind of go through the numbers again. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. So is there going to be a nice number for the cube root of 15? No, but it's going to be somewhere between what? 2 and 3. Do you think it's going to be closer to 2 or closer to 3? Make your prediction now without typing it in. Closer to 2 or closer to 3? Okay. Closer to 2, I heard? Okay, and now let's type it in. We're going to take the cube root of each side. And that is going to give me x is equal to, and the cube root of 15. $2.466. You guys said it was closer to 2, and it's just barely closer to 2, right? Just barely. So what are we going to write down? We're going to write down the cube root of 15. That's our answer. Any questions? Okay, a few more that I want to talk about. This is getting into some advanced stuff. Yes, Sam?
When I do it, I got 3.872988.
Are you sure you typed it in correctly?
It's 3.
Yep. The cube root of 15, not the square root, it's the cube root. Okay. Do you know how to get the cube root in there? Okay. So let's skip ahead. Will you please take a look at, let's go P, and then we're going to skip to maybe S, I think. Let's take a look at P. A squared is equal to 1 over 36. How are we going to do that? If I say no calculators, how are you going to do it? Can you? Put your brains together with your groups. Discuss. It is possible to do without your calculators. What is this going to look like? Any ideas? Yes, Maverick. Yeah, we could square root them separately. Not square, but square root them separately. Exactly. So how do I undo a squared? We take the square root, right? Whatever I do to one side, I do to the other side. But take a look at this. Do you know the square root of 1 over 36? No. But could you figure out the square root of 1?
Yeah.
And the square root of 36? And what's the square root of 1? 1. What's the square root of 36? Let's test that out then. Now let's use our calculators. What is the square root of the fraction? So I need to get that fraction inside of the square root. 1 over 36. It is 1/6. Kind of cool, right? Okay. With that in mind, do you think you could do Q? What's the cube root of 1/27? Because that's what I need. I need to take the cube root of each side. Use your heads first. See if you can avoid using the calculator. What are we going to get here? A few of you already know. Cube root of 1 is 1. Cube root of 27 is 3. So z is equal to 1/3. Oh, I need to go back and fix this. It's not just 1/6. It's plus or minus 1/6. Okay, and now let's move on to something like letter S, and then maybe letter V if we have time. Letter S. We have focused on just undoing one thing and one thing only. But take a look at S now. We have x is squared and we add 16. That's equal to 25. So what am I going to do? Yes, Siley. Exactly. We just have to undo those things. This is our sock. This is our shoe. Take off your shoe. How do you undo adding 16? You subtract 16. And now that leaves me with x squared is equal to 25 minus 16 is 9. And now we can take the square root of each side. And what is the square root of 9? Square root of 9, Sam. Close. Plus or minus 3. Could be 3, could be negative 3, right? It's not a huge deal if you forget that, but by the time you get into 10th grade, you'll definitely want to remember that. So, here is your homework. I want you, I want you to go to the homework section. Man, this is going to be tough. I want you to do enough. I don't know. I want you to do enough. Well, but if I say 9 of them, you're going to do the first 9, and then you're not really going to get the practice that you need. I don't know if I want to do every other one. Okay, do odds. Yeah, do odds. I know. So that would mean you have to do problem number 1, which is an odd, so you have to do all of them. I know. Number 1 is... No, look, listen, you're not listening. Odds. Is number 1 an odd problem? So do you have to do it? You giggle. I giggle too. I want you to do 20 problems. And they better not be just the first 20. Is there only one that you can skip now? All right, let's go 15 problems. 15, is that fair? All right, 15 problems for homework. From number 1. Just focus on number 1, but choose 15 of them. Yeah? All right. It is time to get cleaned up. Thanks for watching. We'll see you next time.